Hello developers, let's start developing. My name is Veko and today we'll be taking on the sixth task of the Advent of Code 2021. Let's see what the task is. Lanternfish. Is a lanternfish? Yeah, it's something, well, I'm gonna say ugly. The seafloor is getting steeper. God carried this way. Massive school of glowing lanternfish spawn quickly for such large numbers. Maybe exponentially quickly. Ooh, exponential complexity. I have a feeling. You should model their growth rate to be sure. Of course, it's an exponential. Or you know, not make some guesses about that attributes. Surely, each lanternfish creates a new lanternfish once every 7 days. Isn't necessarily synchronous between every lanternfish. One lantern might have 2 days left until it creates another, might have four. So you can model each fish as a single number, then represents the number of days until it creates a new lanternfish. You reason a new lanternfish is slightly longer because it has 2 more days for its first cycle. So if we have a single lanternfish with a value of 3, its internal timer will be found 1, 0. Its internal timer would reset to 6 and it would create a new lanternfish with an internal timer of 8. Okay. New lanternfish starts with an internal timer of 8. Does not start counting down until the next day. 100 nearby lanternfish. This. So this is in a several days. Each day a 0 becomes a 6 and adds a new 8. After 18 days there are a total of 26 fish. After 80 days will be a total of that many. How many lanternfish will be there after 80 days? And we have a bunch of numbers. Okay, I have a feeling that this is somehow connected with Fibonacci. The good thing is that the lanternfish are not interacting, so if we manage to get a formula, that formula will work for, we can just scale it out. So in this case we indeed have our input as an array of numbers. So I will just get the test value. I have a feeling that whatever we do for part 1 we'll need to redo for part 2, because I guess the second part might be something like how many lanternfish will there be after 8,000 days, which will run and run and run and run and produce a number so big it won't fit into anything. Actually, it won't produce anything because it will run for several million years. Anyway, processing the input should be relatively straightforward. Input dot split on a space. What is input? Input is a string array, so we're not reading input, we're reading input lines, we're reading input split at a comma and map n to parseInt n with 10. And we need an equal sign, and that should be it. And let's see if we're getting the correct output from this. We should get a list of numbers, list of 5 numbers. 34312, 34312. Yeah, that looks okay. So for the first part I will just we can do this, but we can also do this. So we'll make a copy of the input. And I think that I would like to sort this. Would I? Yeah, I would. And we'll sort them in ascending order. Yeah, JavaScript sorting, so TypeScript sorting as well is a weird beast. So we'll sort them like this, and now we can say, well, we are on the 0th day, and we say, well, day index is less than days, then just loop. And what we will need to return, we will need the fishes dot length. So we're almost done. So for each day that we are doing, well, let's have another indexed. Let's start as 0, that's the fish index, and this will be also a bit not constant, because at the very end of each day we need to move it along. And we can say while fishes of findex is equal to 0, because only the first fishes are basically generating new fishes. So we're gonna we're gonna kind of change this. So if fishes, yeah, let's have it as a naive implementation. I think that I will mess things up. So while we have a fish with an index of it a value of 0, that means that we need to change that to 6, and we need fishes we will just increase the new fish number. And of course we will increase findex. So for each 0 we are counting that it's a new fish. We are setting it to 6 because 6 is the value that we want to actually do. Let's have it as a context constant. That's 6, and that's 8. So we're not setting as 6, we are setting it as a to the max, to the cycle value. So once we run out of fishes that give birth, basically we just continue on. Well, fishes of findex, well, actually the findex is less than the count of fishes. Fishes of findex gets decreased by 1. We don't have a new fish, we move the fish index over. That's all we do. And now we just do for to the number of new fishes, push, yes, 8, that value. So we will add a new fish for each 0 fish. Fish is sort, and I will say console.log end of day that, actually after the inclusion, and log the fishes. Let's see if this does anything at all. Fishy. So at the end of day 0, that's what we have. So after 18 days, 26 fish. After 80 days, let's see, we have 5,934 fish. This looks like it's working. So in a quick and dirty way, we're just gonna try to see. This is the way that I'm solving this right now, is a simulation. So we are taking the requirements and we are running them as we need to run them. And this looks relatively fast. So let's see what happens if we input our actual input. Well, in 324 milliseconds, which is not too much, but not too little, we got some number that is correct. We are done for the part 1. Yep. So it's not 8,000, it's 256. Well, one way to see if this is actually working. It's the exact same algorithm and everything is just the same, only one subtle difference. And this is the issue with exponential algorithms, because they are totally operational until one day they stop working for a value. So you are able to get up to, I don't know, 20, and then for 21 it takes an hour, and for 22 it takes 2 weeks, and for 23 it takes something like 70 years. We have that exact scenario here, that we are kind of doubling the input every 8 days. And let's see how far we get along until we hit a snag. So you can see it is starting to slow down. So for then 144, 149, 150, and we get the feeling, since this is kind of moving forward, that if we wait on it just for a bit, it might get done, but I don't think it will. From what I know of Advent of Code, the value was selected 256 in such a way that is most likely impossible to have it in a finite machine, in a finite thingy. So you can see we are getting right about the 9 million items in an array, 10 million items in our array, and don't forget, we have naively put this here. Well, this means that we are resorting our array each and every time, and that is taking an insignificant amount of time if we have 1,000 items, but once we get to the point that we have 13 or 14 million items, 15 million items, this is getting to be significant time that we are doing this. So yeah, I'm gonna kill this, because even if this manages to do it in an hour or so, or 5 days, Do you really want to watch a YouTube video for 5 days of just somebody staring at the computer and saying, go, 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 one day more, one day more? No, of course you don't. I mean, there are all kinds of people, but I wouldn't want to do that. So, let's think about this. The constants are okay. But what I want to do right now is let's have a hash out of this. As I said, the fishes are independent, and so we have exactly 9 scenarios that are available. So for example, if we define something like this, 0, 0, 1, 0, up to 8, 0, this will be basically our state of the number of fishes, because we don't really care about individual fish, we care only about the number of fishes in each state. But once I look at this structure, there is already such a structure in JavaScript, and it's called an array. So this means that create me an array of how many elements? 9? No, just 9. And of course, fill it with zeros. So we don't even need to do that we will need. So we will need to calculate the state. And for that we will do a simple for of. Now, what is happening? I need this fish of fishes. We will just say that state of fish is increased by 1. And this is not fishes, this is input. And that's all we want to do with the input. So we have our state here. And we don't need the findex. We're gonna do this, and we're gonna return state dot reduce that. That's the sum of all the values. So what we're gonna do each day, of course, we needed this part. So the state of 0. So right now we have an array of 9 numbers, and those 9 numbers are kinda important. So for the state of 0, actually we're gonna generate a new state. I'm gonna do it like this. So from 1 to 9, so from 1 to 8, what we want to do is just move them one piece here. Not this, just this. Actually the other way around. New state of 0 will be the state of 1. New state of 1 will be the state of the previous one. And we will have new state of 8 will be state of 0, because the new guys that get born will be that have the exact number that we are reproducing right now, and those that were from in the 0 state, they are actually adding to the 6 state. So new state of 6, we need to increase that by state of 0. And that looks like all there should be. And we're gonna be logging the state as well. Let's see if this runs a bit faster than the previous attempt. The result part 2 is 5. Yeah, I don't think the result is 5, so we messed up something somewhere. Well, let's go back to the top, and I'll just put in if the index equals 10, well, break. So we're not running the whole scenario, we're just running the first 10 days, and we're looking at what actually happens. I mean, it should be this number, but we got 5. I don't think that's the same number. Let's see what happens. So we had, it says we had 1, yeah. We have 2. Okay, we forgot a very important part that needs to be done, because we're generating the new state here and then we're happily throwing it away. What we need to do is actually say that the state is the new state. Because you can see that the state doesn't actually change. So we started with those 5 fish and we ended up with those exact same 5 fish. We got this number. I'm not even gonna try to pronounce it. I will just copy and paste to see if we have it here. One thing that I might like to do is actually separate this out to see how many digits it has. It has 11 digits, so I'm not worried because JavaScript is fine. All the JavaScript engines are fine up to around 16-ish digits. Basically, what was the max safe? Yeah, this one. Yeah, it's, we need to use number dot max safe integer. So right up until this number, you are guaranteed that operations using integers will result in integers, and we definitely have an integer number of fishes, but you can see that the number of fishes we got was kind of less than this number, so I think that we are safe. Otherwise we might get a situation when our answer is off by on the last digit, so we will have an incorrect answer because we don't have enough precision, and we don't want to do that. So let's have the big input here. Let's remove this since we don't need it. Let's remove this since we don't need it as well. And let's have it running. So in 3 milliseconds we got this huge number. One more check. Let's see. Yeah, it's not 16 digits, so we're safe. It's that many digits. That means if we paste this number here, and we submit it. Yeah, we managed to solve the sixth task without any problems. Of course, once we've done this for the second part, it's kind of weird not to do it for the first part as well. So actually I'm gonna do, and we didn't even need the fish cycle. Actually we kinda need it because this part is hard coded and we don't want it to be. Yeah, removing hard coding, everything. And this will be new fish cycle plus 1. So we don't have, we have some parameters. And this looks so much better. And let's do a bit of doing. Let's refactor this to a method and call it calculate fishes. Fishy. Fishy, fishy, fishy. So we have, this is the fishes value and this is the days value. I will put it somewhere around here. I will put it at somewhere around the top, as it is a helper function. So we don't need this, we need this. Yep. And now our code looks so much better because we managed to hide all the gruesome parts inside the function. Our code looks actively beautiful. And we managed to refactor the first part. And we can see that the running time is a bit less than it was previously. Let's run it in the proper console without debugging, without anything. And we can say that it's even counted faster. So I think that I won't be optimizing this thing anymore. So that is about it. You can see all the code on GitHub. You can check out anything else you want, and of course you can check out the TypeScript workshop as well, because it explains a lot about what TypeScript is and how it works. Thank you and see you tomorrow.